Hello guys, and welcome to my part 1 of EasyEDA circuit designing tutorial. Today we'll be building or designing a function generator circuit as an example for schematic design in EasyEDA. So let's get down to basics with EasyEDA. Now, as the name suggests, EasyEDA is quite easy to use, and let me demonstrate that with the basic stuff of EasyEDA. I've said basic quite a while now. So if you click on EE library, you'll see that you'll get your basic circuit designing components here. Now, these are your basic circuit design components, and these are your generic tools such as VCC flag, 5-volt flag, ground, this type of ground, which never use this ground please, and your net port. So EasyEDA basically provides you with these wiring tools here and your generic components here. But now, as we are building a function generator, we'll be using a quad op-amp ICLM324. So let's start with placing our prime component first. Now, if you want to place a component which is not, of course, available in your generic library, these are just your basic components, resistors, capacitors, everything RLC. You go to libraries here, and EasyEDA basically gives you a bunch of real world components, basically anything that is actually available from a manufacturer. So lessening your chances of screwing up. Now let's just search the component's name, LM324. Well, as you can see, since EasyEDA is yeah. Now, since EasyEDA is partnered with LCSC, which is a part supplier basically, what you get is a library of the, well, in this case the ICs provided by LCSC, and it tells you the number of lists that you got. So now if you click on this, what you get here is an SMD component along with the IC's schematic or schematic representation. Well, we don't want a SMD component. What we want is a PDIP component. So I think all these are SMD. Yep. Uh, for a PDIP component, I guess we will find it right here. Yeah. Yep. PDIP. AN. Let's look for something better. TT. No. Alright. We'll go with this one. So this is your PDIP component, but I don't think this is the right one, since this doesn't look like an op-amp. Let's look here. Oh, oh, where did it go? Ah, here it is. Now, this is standard op-amp configuration, and it is your PDIP socket. Now, there are very less chances of going wrong here with your DIP package, since you can clearly see what you're trying to place on your PCB or even in your schematic. So let's select this, double click on the component, and we'll get it here. Now we'll be needing four op amps, so I'll just place four of them. 3 and 4. Alright, we've placed our primary component. Now let's get to resistors. So we'll be needing quite a number of resistors in this circuit. Now what I personally use are these quarter watt axial zero point 0.4 resistors with the US symbol, which is what I prefer. So click on this, and that's for the selection. So when you click on something over here, that selects what resistor you want, and when you click on here, it gives you the resistor actually. Now let me think up of how many resistors do we actually need. Alright, 1, 2, third one for coupling this, 4, second one this, 5, 6, lost count, 7, 8 and 9. Alright, so now we're done with, let me just zoom into this, sorry. Right. We have placed our resistors, let's place the capacitors. So placing capacitors, now what we could do is I can directly just use capacitors from here, or just use capacitors straight from here, but let me just show you something here as well. So searching capacitor, you get a bunch of capacitors. Wow, surprise surprise. So what you can see is your PCB package and how your capacitor actually looks like, what your capacitor actually looks like. So but there's a literal wide array of capacitors here. Now, I want electrolytic capacitors and ceramic capacitors. So what I just do is I go here, select aluminum electrolytic capacitors, it takes some time, and then voila, what you have is a normal capacitor PCB footprint. But I don't want it to be this wide. I just scroll through this, choose something that fits better. This is better. Right? Yes, this suits perfectly for what was I saying? Aluminum capacitor. Yep. Make sure that you are using the right footprint for your capacitors, because at the end of the day they need to fit on the PCB. What I actually need is ceramic capacitor footprints, but I prefer to go with these because of PCB making constraints. Trust me. It's better to use these. So this, and okay, if you want to rotate a component while you are moving it, press space and you can rotate your components. Fine. Now I don't remember how many capacitors we need. Wait a second. One. Rotate this guy. Press this integrator. 3, and yeah, that's it. The second one doesn't work. Yeah, okay. So we have placed our RC components. Now we need a way to change our function generators. Damn, this is keeps going up. We need a way to change our function generators parameters. So let's search for a potentiometer. Now I'm gonna type in, yeah, what? So YouTube doesn't demonetize me for this. Making source circuit. Alright, this fits. Actually, because I won't actually be placing my potentiometer on the PCB, I can use anything that has 3 terminals. So I'll be using this one. This is US symbol, like that. Alright, all have US symbols. But again, I'm searching in LCSC. What if you want to see generic potentiometers? What do you do then? You just move straight over to system. You have basically more than 999 options. More than 999 options. I hope I said that right. So just scroll through it. Not this. I'm fine with this one, and it also has the earlier one had a European symbol. Sorry, this one has a US symbol. So this, I will click on this for potentiometer. Place my potentiometer. Alright, we're done with arranging the components. Now it's just the connections that's left. Now for the first one, yeah, we also need a ground and VCC connection. So we'll just make those up. Here's our VCC, and yeah, ground. Thing is, you could also just drag, place it here, and this is connected now. So if I drag this away, as you can see, the green line indicates a connection, signal wire. So what I'll be doing, since moving the text, nice. What we can actually do is, instead of making the entire PCB look entire schematic look ugly, in this place individual, oh, I just want to go up there. Individual VCC and ground connections separately. Wow. And you go to your place. Nice. Mixing ground. Three, four. Alright. We've placed grounds for all of our op amps. Now we have to place the RC components. Now, firstly, I'll be rotating this guy like so. Alright. Now we short these two and yeah, I will explain. Oh, if you want to backtrack on something, just right click and yeah, your wire tool is gone. Sorry, I didn't explain this. I'll explain this now. If you want to backtrack, just press Ctrl Z and it backtracks. Now, what if you making connections in the schematic of EasyEDA? What you use is the wire tool. So, as I just did, just wire whatever connections you want to wire. I'll just place it here. Right click. This will be used for later. Now, next connection we need to make is on the output for this one. Alright, output has been connected. The next is the capacitor. So it's here. Capacitor is connected. Capacitor is alright. Capacitor is connected. Now plus. Alright, let me just rotate this component once. You get rotated. Making more projects. Now we connect the non-inverting side here and here. So this acts like a potential divider. This end gets connected to the output, and this end gets connected to the negative side of a capacitor. Now I can just move this a bit, and as you can see, this wasn't connected. See, and now it is. It's always good to check your connections once. Just drag and drop them. Okay, text. It's not cooperating. That's right. All the connections have been made. Fine. Now to the output of your first op amp, we have to place resistor R3 like so, and this goes to the non-inverting input, the inverting input of your second op amp. I forgot a connection here. This goes to the positive side of your capacitor. This goes to the non-inverting input. Sorry. And now we have to make our integrator. So our first integrator specifically. So I let the capacitors above the resistors here. Okay. Now actually, since this is actually showing a polarity, but since we'll be using ceramic capacitors later, this polarity basically doesn't matter. Now we need to connect this here, this here. So this will form our first integrator, and this work with me. Thank you. Here, and this goes to this guy's output. Wait a second. Cool. This goes to this rail through a resistor. I'll rotate this with space, and wow, recording a first video is really tough. I have all due respect for other YouTubers. Right. So this has been connected. Now um, this goes from the output of this guy through a resistor to the output of your third op amp, and rinse repeat, because since this is a function generator. Oh wow, I missed a connection here. Nice. Cool. So since this is basically a function generator, a pretty simple one, this is your square wave output. This acts as a multi-vibrator, and these act as subsequent integrators. So this will form your triangle wave, and this will lead to a sine wave. So your first integrator has already been constructed. Now let's construct the second one, which is basically the same circuit as shown above. And this guy, you know, this guy's also put so the connections. Why won't you connect? Okay, yeah. Alright, finally connected. Fine. Alright, so goes from here, and you go from here to this guy, right? And from your non-inverting input, this goes to this straight. Okay, so your final integrator is done. Now please just get a better output and connect another integrator, another pump circuit. Forgot what it's called. Uh, this goes again to your input, and this time we just need one resistor, no capacitor needed. This connection goes here, and it's not cooperating. Alright, this is done. And from here to R10, R10 goes to your output, and this connection, one time from this mistake to be in a PCB. Alright, so these connections have been done. So now what I would like to do here is actually pick a 4 connector, 4 pin female header. Now doing this so as to get an output on said female headers. Wow, oh, okay. That's nice. Placing the female header here and connecting all of my outputs. Actually I should have picked a third one, right? No, but I want a ground connection as well. So this output goes here. This is connected. This is connected. And oh, sorry, wrong. This is the wrong connection. Well, if you want to delete any connection, standard rules, click on it, press, guess what? Delete. Oh, didn't work. Delete. Got. Alright, so our actual third output is here. Bend the wire a bit, and we want a ground connection for our output. So just create a ground. Snake your way through the circuit, and are we done yet? I guess not, because we haven't still changed the values for these guys. So we'll just name port as 100k. Okay, and if you need to change values on these guys, just double click on the text. If you double click, this appears. This is a 0.01 microfarad capacitor, so I'll just type that at 0.01 microfarad capacitor. Right, and alternatively what else you can do is just click on the part. You'll get all of its attributes, its position, if anyone wants to know that. It's a data sheet for apparently a resistor and the rest of the stuff, and also you can change whatever you want in here, the display name, the prefix, so on and so forth. Well, this is a 10K register. In fact, all the registers are 10K. What we could have done is just copy pasted the entire, just named one register 10K and copy pasted it again and again. But I wanted to show you this thing. And if you want to copy paste something, now that I've brought it up, just right click, copy, standard, paste. See? But you were doomed to die, buddy. Do it. So just rename all of this real quick. 10K, 10K. Alright, these are 10K registers. The 100K one has been named. This guy is a 10K register. Right, 10K. And you are a 100K register. Quite different from these guys. 100K. Alright. And next, this guy is a 0.1 microfarad. So instead of typing in everything, I'll just put 0.1, right? 0.1 microfarad. Same thing on this side. 100 Ks. And this guy's is 100 Ks. I almost forgot. 100 100 K. Right? Capacitors in this end, resistors in this end will be done. Change this. 100K. This is a bit tedious. Try to do as fast as I can. And 0.1 microfarads, 100 Ks. Yeah, you are 10K, buddy. 10K. What's this output resistor? 10K and 10K. Alright, we are almost done naming our giving values to our parts. They have already been named. Okay. So now that our parts have been named as schematic, it's technically almost done. But now let me teach you some additional things that you can do in an EasyEDA schematic sheet. Firstly, let's just move this to a center. So just select everything, click, move. Let's get this a bit more to the center. Alright, thing has been centered. I don't like this name, so I'll just delete the entire thing. Alright, didn't work. I guess you can't delete this. No, you totally can. And this is the header 1. Okay, so now that we have moved it to the center, you can name this thing, double click, function generator. Oh, generator, like an innator. I'll keep that. Generator. Alright, so now you have named your name. You can name your company anything. Name I guess YouTube. Yeah. Oh, okay, I'll keep that. The broken letters. That will took CD. YouTube. Whoa. Can't type today, I guess. T. Finally. YouTube. And yeah. So what if you want to change the logo? So just press this and delete this. Now EasyEDA has some really cool functions, which apart from the standard ones. Oh, let's hit save once, right? And just saved your schematic. You can save it as a module, so on and so forth. What you can do is you can import an image. So let's put an image, select from an image file, and get a bunch of images. Just go to logos. Alright, which one? Let's select this. Okay. So what you can do is you can insert an image. Now place, oops, and resize, of course. You don't have that big of an ego. Going up, logo, space, short. Good. Alright, we are done the schematic. Now, I personally suggest exporting this thing as a PDF. So, export it as PDF. As far as modified, save it first. Alright, let me do that. Save. Now, export as a PDF. It gives you stuff that you want. I just press export. Basically, what engine do you want and the type of your PDF or PNG, and yeah, export. It downloads your PDF straight to your PC. Cool. That's the cool thing about EasyEDA. One fact that it is completely online, so you can access it from anywhere and hassle-free downloads. Okay, so that basically concludes part one. Link should appear around here, I guess, if I can make it work, for part two, which would be PCB design of the function generator. Yeah, well, I guess that's it. If I miss anything, I'll put it in the description. See you guys next time. Bye.